In this video, we're going to go over two topics because they go so well with each other. We're going to go over points of inflection and the second derivative test. Alright, so let's get started. Some graphs have a never changing sign concavity. Alright, some graphs have a never changing sign concavity, such as you have y equals x squared and y equals negative x squared. Alright, so this one the concavity will always be positive, this one the concavity will always be negative. Alright. Also, we have some graphs change concavity. Such as y equals x cubed. Alright, right here is where it changes concavity. Alright, and that is known as a point of inflection, or POI for short. Alright, that is a point of inflection where it changes from concave down to concave up or vice versa. Right, because we know on this interval it's concave down, and then on this interval it's concave up. So the changing point in between is your point of inflection. So now, how do we find these things? Alright, so how do we find these guys? Alright, well, step one, it's going to look really familiar to the last video for a moment. We get f double prime of x. Alright, step two, and there's 4 steps. We get the crits. Alright, step 3, you do your number line. And step 4, points of inflection, or POIs, will only happen if f double prime switches signs. Right? It will only happen if f double prime switches signs. Alright, let's look at an example. Here's our example. We have f of x equals x to the 4th minus 4x cubed. And we want to find the POIs, points of inflection. So step 1, we need to get f double prime. So f prime is going to equal 4x cubed minus 12x squared. So that makes f double prime of x 12x squared minus 24x. Alright, so we got f double prime. Now step 2, we got to get our criticals. Alright, so we got to get criticals. Alright, well, we don't have to worry about the f double prime being does not exist. Alright, so that's good. Now, all we got to do is worry about f double prime equaling 0. So we're going to take the 12x squared minus 24x, set it equal to 0. You can divide by 12, getting x squared minus 2x equals 0. Factor out an x, and you get x minus 2 equals 0. So you get x equals 0 and 2 for our critical values. All right, that's our criticals. So now step 3 is our number line step. So we need to draw a number line, plot our critical values that we just found. All right, so here's 0, here's positive 2. Now what we want to do for step 4 is we want to test and find our points of inflection, because it'll be where they change sign. So test a point here, test a point here, test a point here. So if you plug in -1, you get -1 squared, which is 1. Over here, you get -24 times 1, which is positive 24. So positive plus positive is positive. Plug in 1, you get 12 minus 24, which is negative. Plug in 3, you get 9 times 12, which is a big number, minus 24 times 3, which is a not so big number, so it's a big number minus a smaller number, so it is positive. Alright, so you really don't actually have to work it out as long as you can reason through it and figure out if the answer is going to be positive or negative. So here it's positive, so it's concave up, so we have our smiley face. Here it's negative, so it's concave down, we have our frowny face. And here it's concave up again, so we have our smiley face. Which means that both of these are points of inflection. Alright, so we have POIs at x equals 0 and x equals 2. Alright, it's important to check them because if you remember from last night's video, your concavity didn't always change at your critical point that you found. Alright, so it's always important to check your points for to see if there's sign changes between them. Okay? Now, let's move on to the second derivative test. All right, the second derivative test. So assume x equals c is a critical point for f of x. All right, if f of x is concave up at x equals c, example, f double prime of c is greater than 0, then x equals c must be a minimum. Alright, and also if f of x is concave down at x equals c, example, f double prime of c is less than 0, then x equals c must be a maximum. Alright, so for example, here's your x squared graph. Alright, this is concave up. So since it's concave up, that means this has to be a minimum. And if you look at the graph, it's physically the lowest point on the graph, so it makes sense. If you have the negative x squared, it goes like this. So this is concave down. So your critical point here would be a maximum. All right. So when you look at the graphs, it helps it make more sense that if it's concave down, your critical point is going to be a maximum. If it's concave up, your critical point is going to be a minimum. All right. So let me show you an example. F of x equals x cubed minus 6x squared plus 15. All right, we want to find the extrema. All right, so the first thing we want to do is find our critical points. So we get f prime. All right. Whoops, I forgot to tell you all the steps. So the steps are a little bit different. So let's go back to second derivative, because I forgot to tell you all the steps. So, example. F of x equals x squared plus 8x plus 10. Let's find all extrema. So step one. So now, like I said, these steps are a little different in this case. We want to get f prime of x. Alright, so f prime in this case is going to equal 2x plus 8. Step two, we need to get to criticals. Alright, so we simply, there's no does not exist case, so set this equal to 0 and solve. You can divide the whole thing by 2 and get x plus 4 equals 0. Subtract the 4, so x equals negative 4. Alright, so there we have our critical point. Now what we want to do for step 3 is we want to look at f double prime. Alright, well f double prime, if you take the derivative of that, f double prime of x is going to just be 2. Well, since 2 is positive, that means our graph is concave up. Alright, so we got our smiley face with a little tongue sticking out. Alright, so it is concave up. Since it is concave up, if you look back up here, if f of x is concave up at x equals c, then x equals c must be a minimum. So therefore, x equals negative 4 is a minimum. All right, and that is our answer. We have a minimum at x equals negative 4 because our graph is concave up at x equals negative 4. All right, now let's look at the example. I actually want you all to do this as a you try. All right, so here's our graph. Our function, sorry. I want you to find the extrema and tell me if they are a maximum or a minimum. So pause the video, take a minute or so, and solve this out. All right, so step one, we need to find f prime. All right, find f prime of x. All right, so f prime, first derivative, 3x squared minus 12x. Step two, we got to get our criticals. Step two, get criticals. So our does not exist case does not exist. So set that equal to 0. You can divide both sides by 3 and get x squared minus 4x. Factor out the x. Set both of them equal to 0. So those are two critical values. Alright, so now what we want to do, step 3, we want to get f double prime. Alright, we want to get f double prime. So let's look. Our f double prime would be, let me write that down. Let's see, 3x squared would go to 6x minus 12. Alright, so let's plug in our two critical points. If we plug in 0, f double prime at 0 is going to be, well, that's going to cancel, so negative 12. And f double prime at 4, plug it in, 6 times 4 is 24. 24 minus 12 is 12. So that means this is concave down, so it's a frowny face, and this is concave up, so it is a smiley face. Which means, since at 0 it is concave down, that means that x equals 0 is a maximum, because it's concave down, and x equals 4 is a minimum, because it is concave up. Alright, so that's points of inflection and the second derivative test. Make sure you understand this. Rewind this video, play it back a few times if you need to. It's very similar to what we've been doing, where you find your critical values, you plug them in, and you determine if it's concave up or down. So again, make sure you know how to do this. We'll be working on some problems going over this tomorrow in class. See you tomorrow.